This is 2017 AP Physics 2 FRQ. Let us see what is the question. A group of students is given several long, thick, cylindrical conducting rods of the same unknown material with various lengths and diameters and asked to experimentally determine the resistivity of the material using a graph. The available equipment includes a voltmeter, an ammeter, connecting wires, a variable output DC power supply, and a metric ruler. A. Describe a procedure the students could use to collect the data needed to create the graph, including the measurements to be taken and a labeled diagram of the circuit to be used. Include enough detail that another student could follow the procedure and obtain similar data. Draw a labeled diagram here. Write your procedure here. Next, describe how the data could be graphed in a way that is useful for determining the resistivity of the material. Describe how the graph could be analyzed to calculate the resistivity. Next, the students are now given a rectangular rod of the material as shown below, whose dimensions are not known. The students are asked to experimentally determine the resistance of the rod. They obtain the data in the table below for the potential difference delta V across the rod and the current in it. On the axis below, plot the data so that the resistance of the rectangular rod can be determined from a best fit line. Label and scale the axis. Use the best fit line to determine the resistance of the rod, clearly showing your calculations. After completing their calculations, the students begin to consider the factors that might have produced uncertainties in their results. Number one, the students realized that they did not take into account the internal resistance of the power supply. Briefly describe how this would affect their value of the resistance of the rectangular rod. Explain your reasoning. The students realized that they did not take into account a possible change in the temperature of the cylindrical rods. Should the students be concerned about this? Explain why or why not. Okay. Let us go to the question. Here you have to find out the resistivity of the material. Am I right? Here they gave this one now. Yes, unknown material is given to you. And then using that one, you have to find out the resistivity. See here, this is the resistivity of the material. And using a graph, you have to draw a graph also. Okay. And then available material are voltmeter, ammeter, connecting wires, variable DC power output, and then metric ruler. These are the cylindrical rods they gave. Same unknown material, one unknown material, the material is not known to you. And then you have to find out that one. Okay. Now what we have to do is, this is based on the Ohm's law. Okay. Well, if you know the Ohm's law, then it is easy for you to do this experiment. So draw a circuit diagram. Here, ammeter should be in series with the given rod. This R is the, I'm showing the rod as R, okay, because that is a conducting material. So this is the cylindrical rod. And then it should be connected in series with the ammeter and the power supply with a switch. A voltmeter is connected in parallel to the or across the material, okay, so that you can measure the voltage. Now, what we have to do, you know the Ohm's law, no? Voltage is proportional to the current, or V is equal to IR. So this is Ohm's law. Now, what is R here? I wrote V is proportional to I, or V is equal to IR, where V is the voltage, I is the current, and R is the resistance. And this is the circuit diagram. All the components are given A, V, B, K as the ammeter, voltmeter, battery, and switch respectively. Okay. And then here, according to Ohm's law, V is proportional to I. That means the voltage drop across the conductor is proportional to the current flowing through the conductor, provided all the physical parameters remain constant. Here, all the physical parameters remain constant means at a given temperature. The temperature variation should not be there because the temperature varies, the dimensions of the material will change. Okay. And all the other things will also change. Therefore, and resistance will also change. Therefore, the room temperature should be constant. That you should know. Okay. And then here, V is equal to IR means where R is the resistance. On what factors the resistance of the conductor depends. Okay. Or what are the factors affecting the resistance of the material or conductor. So here, we will see here. I kept it in a table form, the factors affecting the resistance. First one is length. Suppose if the length of the conductor increases, the resistance increases. Okay, because the electrons have to travel all through the conductor, therefore the resistance increases. And then the area of cross section. Suppose the cross section area increases, the resistance decreases. That means the electrons have to travel through the wider tube. Okay, as the tube is wider, the resistance will be less. Am I right? Therefore, the resistance is inversely proportional to the cross sectional area. Same thing I put here. R is proportional to L by A. So R is directly proportional to L and R is inversely proportional to area of cross section. Therefore, R is equal to rho L by A, where rho is the resistivity and resistivity is equal to RA by L. That means resistivity is directly proportional to resistance and area of cross section and inversely proportional to length. Okay, therefore, the resistivity is measured in ohm meters. Okay, resistance is measured in ohms, voltage is measured in volts, and then current is measured in amperes, and then resistance is measured in ohms, and then resistivity is measured in ohm meter. Okay. And then the next one is temperature. As the temperature increases, the resistance increases because the electrons will collide with each other. And then because of the random motion, as the internal energy increases, the kinetic energy of the atoms will increase. And then because of the random motion, they collide with each other and also the walls of the container. Therefore, the resistance increases. Okay. And the next one is material. Obviously, the resistance changes from material to material. Okay. So here I kept the increase in the increasing order. Silver has the least, we go from silver to platinum, silver, copper, gold, aluminum, iron, and platinum, the resistance increases. Okay. So you can zoom it and then later you can go through again. Now, how to perform the experiment? I have shown the circuit, I have given the circuit diagram now. So as per the circuit diagram, you have to connect the rods. He gave the cylindrical rods, no cylindrical rods of unknown material. Okay. So what you have to do is first you have to measure the length of the rod and then diameter of the rod using the ruler. And then here is the tabular form. For each rod, serial number I gave. No? So on each rod, you have to label numbers 1, 2, 3, 4, 5 like this. Minimum 5 rods or 5 to 10 rods. How many rods he gave? Those many for all those rods. You have to measure the length and then diameter. And then from the diameter, you have to calculate the radius. And after calculating the radius, you have to calculate the area. Area of cross section is equal to pi r square. Here I wrote here. A is equal to pi r square. Using the values, you have to calculate. And then afterwards, you have to keep all the, once you finish off this physical measurements, then you take the rods and then start connecting the rods in the, as per the circuit diagram. Make the circuit and then start keeping the rods one after the other and then note down the voltage and the current flowing through the rods. And then you note down those values also here. Okay. And after noting down these values, you have to draw the graph, voltage versus current graph. When you draw the graph, from the graph, you can, so, no, V is equal to IR, no? The Ohm's law. Therefore, R is equal to V by I. Am I right? So V by I means here what it is, rise over run. That means the slope. The slope of the graph gives the resistance. Okay. And then you can calculate the resistance right from the values, experimental values. And because the examiner is asking you to use the graph, therefore you have to plot the values in a graph and then you have to calculate the resistance using the graph. The slope gives the resistance. Okay. And once you calculate the resistance, you know the formula of the resistivity. Just now I gave no resistivity is equal to RA by L. So you have all the values. You calculated the area of cross section of the rod, and then you measured the length of the rod, and then you calculated the resistance from the graph. And then the graph, you plotted the graph, taking the measuring the voltage and current values from the experiment. So with like this, you can calculate the resistivity of the material. Okay. And this is the first part. And after this, what he's asking is someone else has done the, this is a rectangular rod. For this rod, so another student measured the voltage and current, and then the values are given to you. You have to plot the graph. Okay, this is the best fit. Okay. From the best fit, you have to calculate the resistance. Okay, the slope gives the resistance. Here I have taken, and then the scale is also, I mentioned the scale also here. On the x-axis, 1 unit is equal to 10 to the power of minus 2 amperes. That means 1.01 amperes. Okay. Here the like writing is very difficult because the area is small. I can't write. It's so small font, and moreover, that will it's not visible for you if you write. If I write like that, that is why I just multiplied with 10 to the power of minus 2, and therefore it is 0.01 amperes. Each unit is 0.01 amperes. And then on the y-axis, 1 unit is equal to 1 volt. I have drawn the graph, and then this is the best fit. Okay. Mm, line of best fit, and then from the line of best fit, the slope gives the resistance. Am I right? So here is the resistance. Resistance is almost 74, or you can take 73 ohms, because 73.33 rounding you can get as 73, or you can take it as it is. Okay, suppose if they ask for two um, significant figures, then it will be 73. Otherwise, it will be 73.33. I have taken four significant figures because for the sake of accuracy. Then here, and up to this is over. Then next, after completing their calculations, the students begin to consider the factors that might have produced uncertainties in the results. Now, they are thinking that they have not considered the internal resistance of the DC circuit battery. Will it affect the experimental results? No, it will not affect that much, because for each rod they are taking the ratio of the voltage and current. So it will not affect the results, okay, or the calculations. In any way, it will not affect the total calculation of the this one, because for every rod they are measuring the voltage drop across each rod, so that will not affect. And then the next one is the students realize that they did not take into account a possible change in the temperature. Okay. Now, when it comes to the temperature, the students, how much time they are keeping each rod in the circuit? Hardly 2 3 minutes to note down the ammeter reading and voltmeter reading. Hardly they will need 1 minute, not more than that. In that small interval of time, the temperature will not rise significantly, and then it will not affect the uh, resistivity. Okay, so it will not change. Okay, the temperature and resistivity changes. Uh, the temperature will not affect the resistance or resistivity. Here, that is what he is asking. Change in temperature of the cylindrical. Really, should the students be concerned about this? Means they need not concern about the temperature. Okay, of course, the temperature change affects the resistance. As the temperature increases, resistance increases, but it should be a significant increase. How many degrees of temperature the increasing in the fraction of a minute? Hardly, because nowadays they are all in digital voltmeters and digital ammeters. The reading, for to take the reading, it will take hardly 1 minute or 1.5 minutes. In that interval of time, the parameters will not change. Okay, so this is the answer for this question. Hope this helps. Thank you. Bye bye. See you in the next video.